Live. Okay, awesome. Okay, so I think it's mostly new faces here, actually. I don't know if you were at this meeting last year when we did the same presentation. Oh, okay. So this is actually a repeat, so you don't have to follow along if you don't want to, I guess.
And they have questions.
Yeah. Yeah, this is a repeat from last year. I added a couple of extra slides at the end, but we might not get to it because this is a pretty long presentation. So first of all, let's get a show of hands of like how many people are familiar with Git already. Yeah. Okay. Well, then this maybe you'll learn something, maybe you won't. So this is mostly targeted towards people who might sort of know about it, but aren't necessarily like experts at it or whatever. So okay. So first of all, what is Git and why Git? It helps you manage mostly text files. You can actually put other stuff in Git. It helps you basically collaborate with other people and share your code and work together. So these are programs like Git are known as source control management systems or version control systems. You might also hear about other things like Mercurial, SVN, Subversion, CVS, Perforce Bazaar. These are all other systems. Now, one reason why we're particularly interested in Git is because Git is especially popular. You can see that SVN in yellow used to be popular. It reached its peak in maybe like 2009, but Git has been since eclipsed both Mercurial, SVN, and so on. It's very commonly used. And yeah, there's a lot of services built around Git, like GitHub. Okay, so start with why Git? Why should you use Git in your projects? So the first one is you don't have unlimited undos when you're making stuff. So there's often a lot of times when you just wish you could undo a change that you made, but you can't because you closed your text editor, or it's something that you worked on like a week ago, and so on. It's also risky to try new things. Sometimes you're worried about breaking your code, but you want to do like a huge refactor or something, and then you get stuck in the middle and it doesn't work, and it used to work but now it doesn't, and so that's risky. And then the third problem is that it's really hard to collaborate with other people to work on the exact same files. So here's a screenshot of what you might get when you try and work on a file that changes a lot with people over Dropbox, for example. I worked on a project with some people in my undergrad via Dropbox, and you'd end up with like conflicted copies of pretty much everything all the time. And so Git tries to avoid that. So the way that I like to present like what Git does for you is that it gives you superpowers. It gives you 3 superpowers to address each of these issues. So the first superpower is time travel. So because of Git will give you the ability to travel back in time to when you just wish that you could go back in time, Git will let you do that. Number 2, it's risky to try new things. And so what Git gives you as a superpower is the ability to create alternate universes. And so you can actually create whole new alternative timelines, basically, and then you can safely merge them back into your real timeline, or you can just give up on one, and so on. And then finally, to address the issue of like how to work together with people, well, Git introduces like has principled concepts to merging files that have been altered in different universes, basically. Okay, so how to get started with Git? It's very simple. You just type git init in the root of what you want to be your repository, and then it will create an empty Git folder. So then before we go on any further, talk about commits. So commits are kind of like the fundamental unit of work in Git. So you can think of it as basically it's any point in time that you might ever want to go back to or any unit of work that you might want to apply. And so every time you make a commit, you can always time travel back to one. So one general piece of Git philosophy that I think you'll find many people will say is that you want to make lots of small commits that are very focused and modular and focus on just exactly one change. So kind of like before you start typing something, you want to think about like, what is it that I want to accomplish for my next commit, and then you work on it basically. So it's a little hard sometimes to like retroactively make commits for the things that you've done. Okay, so committing in Git is actually a two-stage process. So first of all, there's a staging area where basically you'll edit some files, and then you need to say explicitly which files you want to include as part of your commit. And so when you say git add makefile or git add factorial.java, then those become part of your staging area. And then once it's in your staging area, then you can say git commit to add to actually commit the changes. Now Git Status is what you use to see what the current state of your staging area is, or what the state of your just like what it gives you basically information about your state. So you want to know about this. So so in this example, we've created a folder that has two files in it called factorial.java and makefile. And initially, right after you type git init, if you type git status, you'll see that factorial.java and makefile are untracked, which just means that they're not part of the Git repository yet, or like Git is assuming that you don't actually care about these files. You don't want them in your repo. So you say git add, and then what do you type to add them to commit them? Right. Oh, sorry. Okay. Well, at the time when I made this presentation, I would like practice like all the hidden stuff. But okay. So anyways, git status to see. So when you type git status after git add, now you see that the files are to be committed. Yeah. And then finally, you type git commit to add them to your thing. And you use the -m option to add a message that explains like what the commit is about. And then you can type git log to see a log of all the commits that you've made. And voila, you have the ability to, so if you do this, you at least have the ability to time travel, which is great. Okay, so now let's, does anyone want to point out like maybe a couple of flaws with this with this code? So this is a long presentation, so need answers quick. There's probably like two things, right? So one is that you want to do kind of bounds checking on n, like you don't want it to be negative. And then also another one, which I don't think I actually check here, is that n could overflow. So or for a large enough n, I mean, you can't really compute factorials for things that are too big anyway. So okay, so let's say I make this change. I want to add a little bounds check in there. So now when I type in git status, what's going to happen is that it's going to say that this factorial.java has been modified, but it's not staged for commit. So again, you have to always stage things. So now if you want to take a look at what's changed since your last commit, you can type in git diff, and it will show you, this is called an inline diff. So the minus signs tell you like a line that was deleted, and then the plus signs tell you what was added. And so one way to think about this is that you can try and imagine like what it looked like before, and this is what it looked like before. And then you can, if you cover up the minus sign, you can sort of imagine what it looks like now. So now this is not always the easiest way to read it, and so you can configure a visual tool to use with Git, and then if you use git diff tool, then it will show you like a visual diff of what changed between your files. So this tool is called Meld. I recommend it. It's pretty good. You can also, there's also this other thing I found recently called IC-Diff, which is a command line side-by-side diff, which is pretty good too. Okay, so now, okay, so how do you stage a file? Git add, okay. And then how do you commit it? Git commit, okay, perfect. Okay, so now, how to time travel? So let's say this is our timeline. So we had maybe some initial import, and then we added one commit. So right now there's only 2 parts to our thing. Now, when you type Git Reset, oh, okay. Let me explain one thing. So first of all, master is going to be the default name of your current timeline, and then the little asterisk, you'll see this in Git. It just means that you are currently it just means like you are here, kind of. Okay, so if I say Git Reset and then I specify this commit, and I'll show you how to specify it, then what will happen is that you will be back at your initial, at whatever, you'll time travel back to where you were before, except your changes will still be there. So actually nothing will actually change about the files on your file system. The only difference is that now these changes are no longer committed. So they're still, like, your changes are still there, they're just not committed anymore. So you'll have to add them and reset it. Now, if you just want to completely give up and abandon your changes on the file system, then you can say git reset hard, which will take you back and eliminate all changes that you made afterwards. So if this is what your log looks like, there's two entries in your log. So the way in which you can specify a commit to go back to is that you look at this hash right here. So in Git, they use a content addressable model, which means that all the contents of your commits are basically hashed using the SHA-1 hashing algorithm, and then that becomes the unique identifier for each commit, basically. And so what you do is that you just specify like the first few characters. Actually, you only need to type as many as is needed to be unique. So in this case, you could actually just say git reset 7 to go back here. But usually, like the first 5 or 6 characters is enough to be unique, or like thousands and thousands of commits. So, so now it says unstaged changes after reset factorial.java. So remember, we modified factorial.java. So if you say git status, basically we're back where we were before, where we had made the changes, but we hadn't committed them yet. Okay, so now let's talk about alternate universes. So again, your main timeline is called master. Asterisk means you are here. Now, if you want to create a completely alternate universe, you use the Git Branch command. So, basically, when you say Git Branch and then you specify a name for the branch, like behavior, it actually creates another timeline, or at least this is a way to think about it. So it creates 2 timelines, one called master, one called behavior. And right now, these timelines are identical. Also, Git Branch doesn't actually change where you are. It only creates the new one, but you are still on the master branch. So to jump between universes, to sort of switch between your alternate universes, you can change, you can use git checkout. So if you use git checkout and then you specify the name of the branch, then you will move over to your alternate universe. Now, if you make a commit, then the commit gets added to your alternate universe, but not to master. Now, just for the sake of making it really easy to draw, often these are, or like often you'll see in visual diff or visual Git editors, like you have like this weird like tree looking thing, and you don't see like, you don't really have like this notion of alternate universes in most tools. And that's because they sort of combine the diagrams into one diagram. So here you can see that these are basically the same thing, right? It's just that the first two commits are the same, so they're merged together. Okay, so now if you say, so if you were here before on behavior and you say git checkout master, then this will jump you back to the master alternate universe, which just happens to be the same thing as behavior, but a little bit back in time. So now when you're at the master, you can create another alternate universe called exception, maybe. And then, and again, it will create a duplicate of these two commits, right? It creates a duplicate of the current commit and then everything in the past, but it won't jump you to it. So that's why exception, the exception branch is located here. It's basically the same thing as master. Does that make sense? Yeah? Okay. So now you have three different histories. You have master, you have behavior, and you have exception. And right now you are on the master branch. So now if you say git checkout, you'll go back to the exception branch. And now you can add a commit to the exception branch. And now you can see there's three different alternate universes, but two of them are based on the same one. So, so here you made this commit, and then this commit in the behavior branch. In this universe, you did these two things, and then you did this. And then in the master branch, you only did these two things. So this is a way in which you can sort of explore possibilities, because like if you want to try something, you can create a branch and then try out the change. Okay. So now let's say in these two branches, you're basically just adding a different Java doc comment to this method. Okay, yeah. So another way of thinking about branches, or like another like Git philosophy tip, is that even though branches are great for exploring like things that are really risky and dangerous, it's also just great to do in general. Like, why not make a branch for everything? Because it's really inexpensive. Like, it does not take very long to create a branch, and actually, the code is not actually physically duplicated when you create a branch. Git is just actually smartly like keeping track of things, but it's not actually making copies of anything. Yeah.
If you haven't commit before you do a checkout to different branch, does that all of that just gets lost?
You can't check out without committing. Yeah.
It'll actually get angry at you until you have to either commit or stash your changes, which is like.
Yeah. I think we talk about stashing later. So okay, so you create new branches. So now let's talk about merging. So you've created an alternate universe, and now you're satisfied with the outcome of it. Okay, so let's talk about merge conflicts and merging. So this is one thing that I think some people are a bit afraid of, but actually you can kind of predict when a merge conflict is going to occur, and then they're also not that bad to fix once you actually deal with them. So let's take a look at this. So if you recall, in our factorial.java file, it started out with no comments, and then one branch added one comment, and then the other branch added a different comment, right? And then these two alternate universes are based on the same main timeline, and so as a result, they're kind of like equal. So anyways, what happens is that when you say git merge behavior, it'll take all the commits from the behavior branch and merge it into wherever you currently are, which in this case is the master. So, Git branch will list your branches, and then the asterisk will tell you which one you're on. So that's a way to see all the branches you have. So first we'll merge in the behavior branch, and that works fine, right? All it does is add a comment, so that's not bad. But now what happens when you try and merge the exception branch, which added a different comment into the same place that you added a comment before, right? So now this is a problem because Git is not like smart enough to like know natural language and like smartly rewrite your comment in like a way that incorporates both of what you said, right? It's not that smart, right? So so this is a merge conflict, and so another way to think about so just a simple way to try and think about like how you can anticipate when a merge conflict is going to happen is that you have is a completely different scenario actually that has nothing to do with code. So let's say you have two universes and you have an empty glass to start with, and then in one universe you tell Rosie to fill your glass with milk, and the other one you ask Rosie to fill your glass with orange juice. So in your master you have an empty glass, then you merge in universe 1 and it fills up your glass with milk. And then what happens when you merge in universe 2, right? That's not a good combination, right? You don't want to do that. And also Git is not a bartender. It doesn't know how to mix milk and orange juice in a way that that works. So this is a real conflict, and this is basically like what Git is doing when it detects merge conflicts. So how do you resolve a conflict? Well, the way in which it shows you where the conflict is really simple, maybe a little too simple, but what it does is that it just inserts like these things that won't be valid syntax in any language. It just adds in like these crazy symbols right here, and then and it basically shows you like what are the two alternatives that could be there, right? So this is what we started with. So notice it says head and then exception. So exception is the branch that we wanted to add in that was in conflict, and head means where we currently are. So this is what we had before, and then and then this is what we tried to add, and what we really want actually is to have both. So what we'll do is that we'll combine the two sentences in a way that's smart using our big human brains, and now we can add the file again and commit it. And now they're there. So now I want to show an example in which you can make changes in two branches that don't conflict, and then you'll see that Git is able to merge them smartly. So in one branch, we're going to update the comment that we just added to make it into a Java doc style, and then another branch we're going to change factorial so that it's an iterative algorithm rather than a recursive one. So if we look at what it looks like, here's what the Java doc looks like. It has like some comment, and here is the iterative version of our factorial algorithm. And notice that the comment is still the same. So these look pretty different, and it would be pretty like difficult to merge them, possibly. But what we'll see is that, according to this pre-written slide, is that when you merge in, you'll merge in one, it's fine. It just changes the Java doc. Then you merge in the other, it's fine because it changes the content of the function. So there's actually no conflict there, and it completes the merge by itself. So because the changes are independent and they don't modify the same lines, there's no merge conflict, and Git will actually just apply the changes then it needs to apply, and it won't be a big deal. So, okay, so how do you avoid merge conflicts? Because obviously merge conflicts aren't fun and you don't want them anyway. So the way that you do that is that you want to make your commits very small and focused so that you can get like partial work done. So the idea is that if you have like a giant commit that affects like 20 files or something, right? And then only one of those is in conflict, then like the entire commit won't go through until you fix the merge conflict, right? Whereas if you had made each one of those, if you had made like 10 commits out of the changes that you made, then like 9 of those commits would go through and like 1 of them would fail, right? So you want to make small focused commits. Obviously you want to merge frequently so that you're up to date and that you're not like trying to develop on something that was based way in the past. Or like basically your code base might have changed a lot in the time between when you started working on a feature and when you ended it, right? That's why you want to work on things that are small and fast, and then you can get them into the code base. And then we'll talk about rebasing, and then also just like if you're working with someone, like you can always, hopefully you can like talk to them because they're nearby, or you can email them and say like, hey, I'm about to make like a huge change, like this is what you need to do. So you better get to a clean state quick because I'm gonna push these changes, and you better be able to adapt to them. So that's what I mean by the last one, communicate.
But make sure you don't have your middle finger up while saying something.
Yeah.
Because it might be a little dangerous.
Yeah, so Git will not solve like these social problems. It will just help you with merging your code. Okay, so now let's talk about rebasing. So actually, I'm not sure what this example is trying to say. So let's just go a couple. Okay, yeah, so yeah, let's just skip that. Okay, so anyways, so I think what this is really saying is that no, let's skip that. Okay, so so one example is if you work at a company with a monolithic code base like Facebook, basically that means that their entire, like more or less all their code for a very large company is in a single repository. And so you might get like thousands of commits actually landing in a day or so on. And so if you, and you might work on a feature for like a week or a couple weeks or something like that. And so by the time, between the time when you start and when you end, there might have been like thousands of commits that have changed the code base in the time in between. And so that's risky because there might have been a change that you didn't know about that actually affects you. And so what you want to do is to rebase. So what does it mean to rebase? Well, let's say I started a feature on July 1st, and I created a branch, of course, because when I work on something, I want to create a branch. And then in the 2 days, after 2 days have gone by, there have been maybe like 2,000 commits. So what do I do if I'm worried about falling behind? Well, I can say rebase master. So if I say git rebase master, then this will take everything that I've worked on, and then it just sort of cut, like imagine taking a pair of scissors and just snipping it right here, and then just moving this over here. I realize actually for people who watch the recording, that's not going to be helpful. But anyways, so rebasing basically takes everything that you've done and then it puts it, it sort of replays it on top of a different base of commits. Okay, so what is, so there's many like different kinds of workflows that you can have in Git, but this is at least like one that I could recommend. So the first thing that you do is that you sit down and you decide what you want to work on. And then once you've decided on that, then you say Git Branch to create a whole new universe in which you make these changes. And then you check out that branch. Then you work on it for a while, you make some commits. And then after you make some commits, it's a good idea every once in a while to rebase on top of master and see what has happened. So actually what's missing from these slides is that before you rebase on top of master, you obviously need to update your master, which we haven't talked about that yet. But basically, you need to go to master and then say git pull, then go back to your branch, and then rebase on top of it. Now you can have them erase because things might have changed. So if you have a conflict, then fix them, and then eventually, when you're satisfied, then and you've rebased on top of master again, you can check out master and then merge your feature in. And then when you're done, you can delete your branch because you don't need it anymore. Now, let's say you're working on a feature and then you spot like, you spot something and it's like, wow, there's like this crazy bug here and I could totally fix it by just deleting 3 lines, you know, like it would be a really simple fix. So actually what Git, like kind of like the Git philosophy again, is to make focused commits that do one thing, branches that do one thing. And so you actually don't want to fix this while you're working because that's gonna pollute your branch with a fix, and then you're also denying other people the luxury of having this fix until you're done with your feature, right? So you want, so what you do actually is that after you're done with your feature, you can go in and fix this. Or if you really want to fix it right away, you can use something called Stash. So so let's say you're working on a feature. You have an unclean workspace, so that just means that there's files that you've changed that you haven't committed yet. So that's what this is. What you say is that you say Git Stash, and then basically this is kind of like committing something without actually making a commit. So it will clean up your workspace. It's just sweeping all your changes under the rug. And now it'll say working directory clean. And so now that your working directory is clean, you can check out a new branch from master, and then you can make the fix, you can commit it, and so on. And then once you've made that emergency fix, you can go back to your branch. Let's call it my feature. And then to get back the changes that you stashed before, you say git stash pop. And the reason why it's pop and not like git stash unstash or something like that is because the stash is actually a stack. So you can push multiple things onto your into your stash. So the stash isn't just one thing. It's actually, you can like make more changes and push them onto your stack, and then you pop them off in order. So how do you deal with this interruption? Like, let's say you spot an emergency bug. Well, you spot it, then you say git stash to clean up your workspace. Then you check out master, create a new branch from master, and then check it out. Also, one thing that is not in these slides is that this combination of git branch and then git checkout, the same branch, is very common. And so there's a shortcut for this, which is just git checkout -b, which will create a new branch and check it out at the same time. So okay, so now you've created a bug fix branch from master. Then you fix it, then you merge it back into master, then you go back to your feature, and then you can rebase your feature on top of master. And or you can rebase on top of master, and then you can pop whatever unclean changes there were. So basically, like, while you were working on your features, you may have made like 10 commits, and then you're working on your 11th. So the rebase will add in the 10 commits that you changed, and then git stash pop will add in the 11th commit that you were working towards. Basically, it'll add the stuff that you were working on. Okay, so probably many people here have used GitHub or are using GitHub actively, and so I thought I would just toss in some slides about like how to use GitHub in case there's some people who aren't familiar with it. So one thing to remember about Git and GitHub is that they're definitely not the same. So Git is like a program. GitHub is a company that offers web hosting for Git repositories. And another thing about Git is that there's actually basically you can create many copies of a Git repository, and they're all considered to be equals. So no one's repository is really like better than others. But that's kind of difficult, right? So let's say like everyone in the lab is working on like the Amazon picking challenge or something, right? We each have our own repository for the Amazon picking challenge, and like how do we share code if none of us is like has like the master branch, you know, like if we're all equals, right? Like whose repository is the best, you know? And so one thing that you do is that you just sort of have to pick one of them to be the best. And it turns out that you know, you could just pick the one that's on GitHub to be the best one. So that's what I mean by the source of truth, basically. So this is, you can call this like, you know, you can host your Git repository, a copy of your Git repository on GitHub, and then just declare that one to be the king of all the repos, and then you can work on that. And then all the copies of a repository that aren't yours are called remotes. So okay, how to create one? It's actually surprisingly like it's a surprisingly small button, but or it's surprisingly like, I don't know, maybe they changed it, but there's a button called create a repository that's like in the top right corner of GitHub. So you click on it, add a name, add a description, choose whether you want it to be public or private. So on GitHub, you don't have private repositories by default, but if you have an edu email address, then you can email them and ask them for an academic license, and they'll give it to you for free. And that gives you up to 7 private repositories. Another option is to just use a different service like Bitbucket, which gives you unlimited private repositories, but which limits the number of collaborators who can work on a repository. So GitHub, you have unlimited collaborators, but limited private repositories. And Bitbucket is the opposite. You can also, if you're a UW, if you have a UW account, then you can also use gitlab.cs.washington, which is like a new thing that the CS department is hosting. They have a thing called GitLab. And also, like one thing that some people don't know about is that you can also add a git ignore file from GitHub. So I have a slide on git ignore files, but basically, like they have one for RAWs, they have one for Python, Java, blah blah blah, and it will just basically keep things out of your repository that you don't want to be in your repository normally. Now, let's say someone is working like you're working on some project and you want to make a copy of someone's code so that you can work on it. Well, here also there was like another tiny box, which is kind of hard to find if you don't know where it is, but here it is. And then you want to click this tiny button that says SSH, hopefully, to clone it, or I recommend using SSH to clone it. And then you run git clone, and then you copy this URL to make a copy of it on your computer. So this is very common for like RAWs packages and stuff like that. You'll like, copy them to like your Catkin workspace. Now, how to push and pull commits between repositories? Well, basically, let's say you're in your master branch. So the name of, I think the name of the repository that you cloned from is going to be called origin by default. So remember, remotes are Git's term for copies of a repository. And then, so the default name of the repository that you made a copy of is going to be called origin. And so often origin is like the GitHub repository that you cloned. So when you say git pull origin master, what this means is that you're asking for the master branch from origin, and git pull means merge in the changes. So this will merge in changes from GitHub's master to your master, or you're in your master. This will merge it into wherever you are currently, basically. So it's a good idea to keep the names of your branches roughly the same so that you don't get confused. Now, if you want to take your changes and push them up to GitHub and make it available to everyone else in the world, then you can say, then you go to whatever branch you want to push up, and then you say git push origin master. So again, you name the remote that you want to push to, and then you can specify the master branch. Actually, also another like little known thing is that you can have more than one remote, and you can have like different things. And so actually, like all these computers here in this lab are networked together, and so you can actually add remotes to repositories hosted on, or to other repositories on other computers. And so if you just construct the URL correctly, it would be like wally.cs.washington.edu : path to GitHub repository, and you can actually push and pull just between these computers without going through GitHub or something like that. So pretty cool. Now, what happens if you're working on a project and so normally you actually can't push, or you can't push to repositories on GitHub unless you are like a member of that repository, and they have like control. They have like a form where you can add like GitHub usernames for like people who are allowed to push to your repository. So if you don't want like randos on the internet like pushing to your repository, just don't. Yeah, then they can still make a contribution, but what they'll do is that they'll create a pull request. So this is a feature of GitHub where there's a graphical interface for merging in changes from other copies of the repository from users who are not allowed to push to your thing. So anyone can make a copy of your repository, and then they can submit a pull request, but they can't push directly to your thing. This brings us to forking. So again, forking is a feature of GitHub. It's not a feature of Git. So Git making a copy of a repository is called cloning, and then on GitHub it's called forking. And it's basically just like a one-click button to make a clone. And so let's say I have a repository called Programming by Dancing, and then Mike wants to work on it. So he clicks the fork button on GitHub, and then that will create a copy of this repository called Programming by Dancing on his account. And then now I'm going to clone the repository on GitHub to my local computer on Robotuna. And then let's say Mike is working on Unimate, so he's going to make a clone of that. So now actually there are 4 copies of this repository in the wild, right? There's mine on GitHub, there's Mike's on GitHub, there's mine on my computer, and then there's Mike's on his computer. Sometimes people in the lab talk about like forking each other's repositories and stuff like that. I think that's actually like probably not a good idea. So what you should do instead of creating forks of each other's code is that you should just add them as members to your repository, because that way you're all sharing like one source of truth, right? So if you have like 10 members on a project, you don't want to have 20 copies of the same repository. You just want to have 11, right? You want 10, which are, you know, each of the 10 people has their own, and then there's GitHub, you know. So you kind of want like this sort of like master-slave architecture, as opposed to like a massive like duplicate thing. And what happens is that when you make a fork of someone's repository, and then you know, like I push to my GitHub and Mike pushes to his GitHub, and eventually we're going to make so many changes that these 2 repositories are going to be so different. And then the only way to merge them together is through pull requests and so on. So it starts to get messy, basically. Like you might as well just, if you know the person and you trust them, you might as well just share one repository. So that's my personal opinion on forking, at least in this lab. Okay, git ignore file. So you create a .git ignore file and put it in your repository, and Git will basically not track files that are listed in there. And then, so here's an example of a git ignore file. So maybe you want to not include like a.out, or you want to exclude an entire folder, or you want to exclude all of a particular type of file using star dot blah blah blah. So these are all things that you could put in your git ignore, and you can look online for how to do them. And then if you use GitHub, it has like frequently used git ignores kind of when you create a repository, and those are really good. So, and it also doesn't really hurt to have like extra entries in your git ignore that aren't actually in your repository. So you can like ignore like ASDF, right? And like it's not going to cause a problem. So what kind of things should be in your git ignore file? Well, stuff that I think like the general idea behind like what you don't want to include in source control is stuff that can be generated by your code, or generated through some simple process, because those things aren't really fundamental to your code, and you don't want to have like commits that are just like huge changes by like to like generated code, you know. So for example, I mean, it's not even really possible in ROS, but like you wouldn't want to include like the generated ROS messages in your thing, because every time you change the message, then like, anyways, like, okay, so no generated code, no other generated stuff, no package manager copies generally, and no executables, because executables can be generated by your code. So, okay, SSH keys. So if you don't have SSH keys, then you'll have to type in your username and password every time you want to push, pull, clone from GitHub. So making an SSH key is really simple. Just type in SSH keygen, and then you can optionally say -c and add in like your email address or something like that. And then once you have your SSH keys set up, you can use this command SSH copy ID, which will allow you to SSH into another computer without typing in a password. So here, for example, I have copied my public key to Rosie right here, and now I can log into Rosie without having to do anything. Now on GitHub, to be able to do GitHub stuff without SSH keys, just go to github.com/settings and then click SSH and click add SSH key. And then the GitHub like instructions tell you to like install this weird program called Xclip and then run it. And then basically all it does is that it copies like the contents of a file to your clipboard. And so like, I don't really know why you can't just open it in Vim and copy it in, but I've done that dozens of times and it works. So yeah, just copy the contents of your public key in the key field, and then you should be able to push and pull from GitHub without any problems. Okay. Interactive rebase. So sometimes you'll go to a repository written by someone else, obviously not anyone in this lab, but and you'll look at like the commit history, and you'll see something that looks like this, where like they added some feature, and then there's just tons of like commit messages that are just like ASDF, like they don't really know what to say, or they push something that was buggy and then they added another commit that fixed it, and that's kind of like, I mean, that's not a big deal, but it might be like a little bit embarrassing to them. Yeah. So one.
All my comments are like that, and then.
Yeah. So.
I just never rebase. Yeah.
I mean, one thing is that like who's really going to care, I guess, but if you are in a situation in which you do care about it or something like that, then what you can do is that you can actually combine multiple commits into one commit. So let's say you have like your main commit, and then you have a bunch of them that sort of fix it. You can combine all of these into one commit by using interactive rebase. So the way you do that is that you do rebasing as normal, but you pass in a -i option, and then it has like this little, it'll open up a file with like a little tutorial in it on how to use it. But basically what you want to do is this squash command. So you say pick, which means like this is the main file, the main commit that you want to use. And then you add in squash to fold like this commit into this commit. So squash will fold a commit into the previous one. So there's other options other than pick and squash, but yeah, I'll leave that to you to figure out. Git bisect. So let's say you are working on something and you notice like there's this bug that used to not be there, and you want to know like what's causing this, like when did I introduce this bug? Because like a week ago, like this thing was working, but now it's not, right? So Git bisect is really powerful. Basically, it does a binary search through your timeline, and then you can isolate the bug by marking commits as like good or bad. So the way you use it is like you say git bisect start, and then you mark your current situation as bad. Then you go back in time to like some time where you're pretty sure the bug wasn't there, and then you mark it as good. And then once you do that, Git will start checking out the midpoints between your good and bads, and it will find the first commit in which the bug was introduced, or the first commit that you marked bad, basically. So yeah, that's pretty awesome. It allows you to quickly find bugs. And then I think actually the last topic we have here is Git cherry pick. So you might there's situations. I mean, so these are slides that I added last night, basically. So I didn't really put as much thought into them, but there could be a situation in which you only want a single commit from a branch. Like let's say you have 2 branches, and one of the branches has like has like one interesting commit that you really want, and then like 5 commits after that which you don't want because they make other big changes, right? So you might want just one commit and bring it into your branch. So git cherry pick is your command for that. So just use git cherry pick, and then you specify, like let's say, I mean this is kind of maybe what I should have done was git cherry pick B instead of C, but in this case you could cherry pick C. And instead of C here, you would type in like the SHA-1 commit hash, like the first few characters, like we talked about before. And this will create a new commit that applies the changes that occurred in C to your current branch. So okay, so if you're interested in learning more about Git, you can always use the git help command. So you can either type in git help by itself, or if you want to know more about a command, like let's say you want to learn more about polling, right? Then you can say git help poll or git help bisect or whatever like that. We also have a page on our HCR Lab internal website, which is may or may not be helpful. It basically has like these slides in it. Pro Git is like a kind of like the authoritative book that's featured on the Git, the official Git website. So you could read it. Git cheat sheet is interesting. You know, it's just a cheat sheet of commands. And then learn Git branching is like this really cool game, which yeah, you just have to try it basically. So the link is in the slides, but it's basically like it has like a little Git simulator in it, and then it like asks you to do certain things and has a visualization of what you're doing, and then you have to pass the levels by doing the right commands. So it's pretty cool. And that's all I have. So yeah, finished on time. Any questions?
Do you know if there's any difference between Git Stash pop and Git Stash apply? Because I always use apply, but I always assume they do the same thing.
Yeah, I don't know.
Doesn't pop, so like so I think if you do apply, the thing you applied is still on the stack. But if you do pop, it's not.
Okay, yeah. So for the recording, the question is pop, Git Stash pop, and Git Stash apply, and what's the difference? And I think it sounds like the difference is that apply will apply something that was in your stash, but not remove it from the stack.
Confirm this on Stack Overflow. The link is purple. I don't know. Obviously, myself more than once.
All right. Stack Overflow says it's true. So, other questions? Cool. Okay. Thanks very much.